Hello, good day everyone. I'm Devilakshmi Promindan from Group 1. We'll be presenting the report of the third experiment, which is the application of first law and second law of thermodynamics. A group consists of Aina Alia, Ahmad Diawuddin, Darshana, Me Divya, and then Muhammad Saifuddin. So let's see the abstract and the objective of this experiment. This experiment was carried out to apply the first law and second law of thermodynamics in various processes. In the experiment, we used two different initial temperature of water, which is cold and hot. With the interval of 1 minute, the temperature of both water is recorded until it reaches the thermal equilibrium. Towards the end of the experiment, the hot water temperature decreases while the cold water temperature increases and both reaches the thermal equilibrium state. The temperature of both water and at thermal equilibrium is at the range of 35 degrees Celsius to 40 degrees Celsius. A graph of both cold water and hot water temperature against time was plotted. Nextly is the objective of this experiment, which is to apply the first law and second law of thermodynamics in various processes. Next, I'll pass to the next presenter. Thank you.
Hi, Assalamualaikum. My name is Aina Alia bint Abdullah, and today I will explain about the theory and related application about this experiment. Energy balance, or the first law of thermodynamics, is a basic calculation of heat transfer. The energy balance for the system is E in minus E out equals to delta E system, and then delta U system is equals to 0. The delta U system is equals to delta U hot water plus delta U of cold water, which is also equals to 0. And then the whole derivation for the equation is equals to mCp delta T hot water plus mCp delta T of cold water, which O is equals to 0, where m equals to mass in kilogram, Cp is the heat capacity in kilojoule per kilogram Kelvin, and then T temperature is in Kelvin. Closure statement saying that the heat can be transferred from the hot reservoir to the cold reservoir easily without doing work.
Hi, my name is Darshana Krishnan from Group 1, and today I will be talking about the methodology involved in experiment 3, application of first and second law of thermodynamics. So number 1, we weigh two different sizes of empty containers. Next, we fill the larger container with a little amount of cold water and weigh the mass of cold water. Number 3, fill the smaller container with hot water, approximately 80 to 90 degrees Celsius, and weigh the mass of hot water. Number 4, place the hot water container inside the cold water container as depicted in Figure 1. Figure 1 is attached on this slide. Finally, record the reading of both water temperature for every 1 minute until they reach the same temperature, which is thermal equilibrium. That is all from me. I'll be passing on to the next member. Thank you.
Assalamualaikum and very good morning to all. My name is Muhammad Saifuddin Khan bin Nazaruddin. So I'm going to present about result and discussion. So first of all, we see the result. The temperature of the initial hot water is 80, and after 26 minutes it dropped to 38 Celsius, and then the temperature of cold water initially is at 28 degrees Celsius and it drops to 36, it increased to 36 degrees Celsius. And then we see the data. So the heat capacity of water is 4.187 kilojoule per kg Kelvin, and then the mass of hot water used is 0.1980 kilogram, and mass of cold water used is 0.8352 kilogram. So moving to the next, which I plot the graph of water temperature versus time for both hot water and cold water. So the blue line represent the temperature of hot water, and the orange line represent the temperature of cold water, and the blue dotted line is the linear line, which will give the equation of y equal to negative 1.069x plus 59.563. And then the dotted line of orange dotted line represent the linear line for this orange line dotted, which give the equation of y equal to 0.0397 x plus 36.262. And then to calculate the energy change for both hot water and cold water, we use these equations, which is total change of internal energy system is equal to energy in minus energy out, and then the total change of internal energy system is equal to 0, and then total change of internal energy system is equal to change of internal energy of hot water plus change of internal energy of cold water. And we use this equation to calculate the result. Moving to the calculation, to calculate the energy change for both hot water and cold water, we use these equations, which is total change of internal energy system is equal to energy in minus energy out, and then the total change of internal energy system is equal to 0, and then total change of internal energy system is equal to change of internal energy of hot water plus change of internal energy of cold water. And we use this equation to calculate the result. Moving to the calculation, temperature change for hot and cold water will be calculated by difference of the initial value, final value minus initial value. So for the hot water, 38 degrees Celsius, which is the final value, will be minus with the 80 degrees Celsius, and the final value is 49 degrees Celsius. And for the cold water, 36 degrees Celsius minus 28 degrees Celsius, which will give us 8 degrees Celsius. And then to calculate the energy changes for hot water, we use this equation, and we get negative 40.62 kilojoule, which represent that energy is meaning the energy is released. And then the energy changes for cold water, we get positive 27.98 kilojoule, meaning the energy is absorbed. And then the total energy change in the system, we calculated by plus both the value, we get the negative 12.64 kilojoule. For the discussion part, while experimenting, it is observed that the temperature of hot water drops more rapidly at the beginning stage compared to the temperature of cold water, which gradually increase until after 26 minutes, where both hot and cold water achieve thermal equilibrium. The transfer of energy between these two mediums obeys the first law of thermodynamics, which the total of an isolated system is constant. Hence, energy can be transformed from one form to another, but can be neither created nor destroyed. The gradient of graph represents the rate of temperature changes from the beginning to the end of the experiment. According to the graph 1, hot water release energy as it shows the negative gradient, which is y equal to negative 1.069x plus 59.563, while the cold water absorbed energy as it shows the positive gradient, which is y equal to 0.0397x plus 36.262. So the magnitude of the gradient depicts that the hot water releases more energy compared to the energy absorbed by cold water. This is because a bigger mass of cold water used compared to hot water. Besides, the temperature of hot water decreases while cold water increases as time passes by. It shows that the heat transfer obeys the second law, which heat is transferred from high energy level to low energy level. Finally, due to this experiment being conducted in an open system, not all energy from the hot medium is transferred to cold medium. Hence, some energy in the form of heat will be released to the surrounding. So, next part is conclusion will be shared by my another friend. Thank you.
Hello, my name is Ahmad Didarif and I will be continuing on for the conclusion part. In conclusion, the experiment proves that the first law and second law of thermodynamics is true and valid. The first law states that heat energy cannot be created or destroyed but can be transferred from one location to another. This is proved by heat being transferred from the beaker containing hot water to the cold water. As for the second law, it is stated that as more energy is transferred or transformed, more of it is wasted. This is proved by the transfer of heat energy from the hot region to the colder region. Errors in data are caused by human errors such as the incorrect reading of the thermometer and incorrect intervals of 1 minute or the stopwatch. Thus, the objective of the experiment is reached. Thank you.